Hello my beloved, believe you have subscribed. So, have you ever wondered what happens to stars when they grow old? Well, we're about to find out. My name is Deborah, and welcome to Mainstream. When a star approaches the end of its life, and helium nuclei begin to fuse in its core, it will bloat dramatically and turn into what's known as a red giant star. After swallowing nearby objects, it will grow so large that it can no longer hold on to its outermost layers of gas and dust. In a glorious denouement, it will eject these layers into space to form a beautiful veil of light, which will glow like a neon sign for thousands of years before fading. The lifespan of a star is largely determined by its mass. In general, the more massive the star, the faster it uses up its fuel supply, and the shorter its life. The most massive stars can burn out and explode in a supernova after only a few million years of fusion, whereas a star with a mass similar to the Sun can continue fusing hydrogen for up to 10 billion years. Supermassive stars swiftly run out of fuel depending on their mass, resulting in core collapse supernovae, one of the universe's most explosive explosions. A supernova's radiation can easily outshine the rest of its host galaxy. Depending on how much mass is left, the Death Star's core will either become a neutron star or a black hole. This is because when stars with masses less than 1.44 solar masses, like the Sun, run out of hydrogen to fuse in their cores, they inflate into red giant stars and share their outer layers. A remnant of a white dwarf star, similar to neutron stars, remains in this planetary nebula. Unlike neutron stars, white dwarfs no longer convert hydrogen into helium. White dwarfs will eventually turn into black dwarfs, though it's interesting to note that no black dwarfs have yet been observed, because a white dwarf takes longer than the current age of the universe to fade away. This is because a white dwarf depends on degeneracy pressure for the support this time. But instead of the neutrons, it's the electrons that are degenerate back together and forced into higher energy states.